Okay, so welcome everybody. Today we're going to be talking about code style. So let's start with why code style is important. So you write code once, or sometimes you rewrite it to improve it, but it's written once or a few times, and it's read many more times. It's modified many times, and often it's not by the original author. So your goal is to make code that doesn't just work. It's easy to read, it's easy to understand. Code that's hard to read is a problem for a few reasons. It's bug prone, first of all. People don't understand it, they can't really reason about it. There are usually cases it doesn't handle that nobody understands. It's hard to modify. If you don't understand code, it's kind of a black box and you're scared to touch it. And it's challenging to reuse it. If you don't understand what exactly this code does, you don't understand the pieces of it, it's difficult for you to go and reuse that in some new function that might benefit from it. So it's basically very important. In industry, this is taken very seriously. In my team, we took it very seriously. We're spending huge amounts of money to develop complicated software. If that software is not readable, it's kind of a waste, right? We're not going to be successful in the long run. And every company that writes software, which is pretty much every high-tech company, understands this. So today we're going to talk about guiding principles of how to write readable code, and then dive into a few important but high-level recommendations. Some of the important things you want to do is functions. Watch how long they are. Variables, make sure you name them well. We're going to talk about how many temporary variables are good in your code and what scope you should use in your variables to make them more readable. Comments, and how to avoid duplicate code. And there are lots of other things you can do for good code style we're not going to cover. We're going to talk about some more in lectures, so you get some more rules there too. And it's something that you'll continue developing on throughout your career. It's like learning to become a good writer or a good communicator. You keep learning for a long time, so you see how to make your code easier for others to understand. Okay, so guiding principles. So the two most important things you're trying to do when you're writing code to be readable is to reduce cognitive load. So cognitive load is how many things do I have to keep in my mind at once. Programming fundamentally requires understanding a lot of details, and human working memory can't actually keep that many things active. So there's a famous study by Miller that showed that human working memory, the number of things we can keep right at the top of our mind, is about 7 things plus or minus 2 items. So there's some variation across people and what you're doing, but it's not a huge number of different things. And this is why phone numbers are actually 7 digits long. So now most of you have probably grown up in a world where you use your cell phone and it just remembers all your friends' phone numbers. But when you actually have to remember a phone number, people are pretty good at remembering 7 digits. They can memorize that, and they'd be pretty bad at memorizing 11-digit numbers or 10-digit numbers. So that's why we have 7-digit phone numbers, and then we have area codes that don't have that many unique combinations. So we want to do the same thing in code. Try to minimize how many things a person has to keep in his or her mind, and we're going to talk about some ways to do that today. The other thing you want to do is explain the why. So a person can read, if the code's well structured, a person can read it, they can understand what it does, but they usually don't understand why does it work this way. What's the big picture? What were you thinking? What are the assumptions? When you wrote the code, you hopefully had a guiding principle, you understood your assumptions, but now the person reading your code doesn't know where you are and can't ask you. Even I will read code that I wrote months or years ago where I knew what I was thinking when I wrote it, and then I come back months or years later and I'm reading my own comments and they're very helpful to me. So I am the original author, but I don't remember what exactly I was thinking or why I did it this way. But if I wrote it down, it's helpful even to me. And it's even more helpful for someone else trying to read your code. Okay, so those are kind of the big picture. Keep those in mind. And then let's look at how we can use certain targeted techniques to achieve that. So functions. You want to have many short functions, not a few long ones. So if a function is longer than a relatively short number of lines, about 10 lines, it smells. So earlier tutorial, people asked, what does that mean it smells? It just means it works, but it's kind of like you open your fridge and there's a bad odor in it. Like, is some of this food you're a bit worried about? It's not the best. How do we get such long functions? Sometimes it's the original author just wrote long functions, which you really shouldn't do. Try to break it up into smaller helper functions. Another common way that you get long functions is it's basically just a slow degradation. You write the function and then you later think, oh, I missed this case. I just need to add a couple more lines. Then I missed this other case. I need to add a couple more lines. And now there's another feature, add a few more. And pretty soon your function is too long, has too many if statements. It's hard to follow. So you don't want to do that. As you keep adding these 2 more lines, you have to, at a certain point, say, I'm going to break up this function. Okay, it was 1 function, now it's going to be 3. Each is going to do a smaller role. So why are long functions bad? They're harder to read, they're harder to understand, they're harder to maintain. They exceed your working memory. You have more things to keep in mind as you're reading this long function than you would have in a short function. Short functions force you to name parts of your code. So the fact that you give a function a name tells a person, if you've named it well, what does this do? So as they're reading code, if they see a short function that in turn makes a bunch of calls to helper functions, that short function is reasonably easy to understand. If you only need to understand the high level of what it's doing, just reading the names of the functions it calls gives you a pretty good idea of what's going on. It's also much easier to reuse code if you use short functions because, well, you have named pieces of functionality, and if you need to reuse little bits of that functionality, it's easy to do. If you have a long function, it does many things. It's unlikely that you're going to find a use for it later. But if that long function was actually made into a shorter one that was calling helper functions, it's likely you can use those helper functions again. Okay, variables. So you want to name your variables well. They should describe their contents and their purpose. So I know what this thing is and what it's for just by reading its name. You don't have to go back and look at the declaration and how it was initialized unless you really need more detail. You got a pretty good idea just from the variable name. So yeah, I don't want to see, except for really simple counters, we really don't want to see variable names like I, J, K, val in your code. Your name should be a lot more descriptive than that. Temporaries. So temporaries are kind of a just right thing. I would say you can have too few temporaries and you can have too many temporary variables. So let's first talk about scope. You can declare variables in various places in your program. I'm going to show you examples of this in a few minutes. But basically, if you declare them at the smallest scope, so they're not visible for most of your program, it makes it easier for people not to keep as much in their mind. It's easier for them to reason about your program. So use local variables instead of global whenever you can. So that'll be one rule that I'm sure you already know. But you can go even further than that. If you have small functions and you declare variables inside your functions, well, those variables have a smaller scope because they're only alive for that small function. And you can go even smaller. You can declare variables just within blocks of code. So within if statements, within for loops, etc., and have even smaller scope than in a function. And if that's all you need them for, it's better to declare them that smaller scope. Temporary variables. Some temporary variables can be useful. They kind of name your steps. You can show intermediate calculations and give them a name, so that can be helpful. Too many temporaries where you're just renaming variables. You're saying j equals I and then k equals j for no reason. There's not really a whole lot of reason that you have these 3 variables and moving in lockstep. That makes your code harder to understand because you need to remember all 3 of these variables are kind of synonyms for each other. So be careful of that. Okay, so that was principles that we're now going to apply concretely. It's difficult to actually develop a good code style without practice, just like you can't become skilled at writing essays by just reading rules of how to write essays. You have to actually do it. Okay, so let's start with this piece of code. And this piece of code is actually one of the functions you have to write for milestone 1. So find street segment length, takes in the ID of a street segment index, and it has to go figure out how long is it. And it has some work to do because we've got latitude and longitude points, but we can't directly compute distance from latitude and longitude. We have to kind of call a function that understands that the Earth is curved and so on. And our street segments might have not just endpoints, a from and to intersection. They might also have curve points in between. Okay, so you see there's an if statement here checking that. Now exactly what this code does isn't all that important. We're just using it as an example of style. So let me fire up a poll here. I want you to tell me what you think of its style. Okay, so using some of the points we just discussed about short functions, variable naming, temporaries, etc. Anything else that you want to comment on, what do you think of its style? If you were the TA, how would you grade this? Because your TAs are going to grade your code style. So there's a purpose to learning about this immediately as well. Okay, so I'm going to give you a few more seconds to make your vote. We got most people have voted. And so if you haven't voted yet, just take a shot at it and I'll share the results. Okay, so we got everybody. Let me share these results. Okay, so 30% of people thought it was good, but there were minor improvements possible. 43% thought it was fair, but significant improvements were possible. 22% thought it was poor, so there are lots of style issues. And one person said, can't read C++, should only read Python. So yeah, I put that in there to see who loves Python. Python's, you're going to wind up learning multiple languages, but you also have to know a high-performance one like C++. So, so I think you guys are about in line with where the TAs would be and where I would be on this code. I would probably rate this code as fair, so kind of in the middle of what you said. That was the most popular answer. But you could make a case for it being, poor or maybe, I don't know, it's probably not quite good, but that's not too far off fair. So you're thinking about the same range the TAs are. I would rate this as fair. Okay, so in the chat, most people rated this fair, nobody rated it as perfect, so everybody's got some thoughts on how this could be better. Why don't you type in like why? What could they have done? Or unmute yourself and just say what you think. But what could be improved? Okay, so Simon's saying there's no need to define inter 1 and inter 2. So you don't like these temporaries. You think these temporaries are not super useful and they're making it a little harder to read. I think it's a good point. I think that's certainly a very valid argument. Right, so we got these temporaries and they're immediately just used here. So you're saying get rid of them, be easier to read. Okay, any other comments? Is that the only thing that you think could be improved here? I think there are other things. We'll go through some of them. Let's see how many of them you can get. Okay, yeah, so you could add some comments. So should have comments for sure. I'm not going to talk about that for a while, but definitely. The most important comment that they're missing is on top of the function. So you want someone to understand what does this function do. So if it's being called in some higher level function, they can hopefully figure out what it does just from its name. If they can't, they go to the header file. And in the header file, there should be a comment saying, what does it do? And hopefully that tells them enough that they know. And only if neither of those two things show them enough do they go to the function and then read the code. So you want to have a comment for sure saying, what exactly does this do? And in this case, you can't edit the header file for this one. So you want to put a comment above this function saying, what does it do? And then inside of it, you may have some comments too. That would also be good. But that's the most important one, top of the function. Naming of lat longs. Okay, so someone doesn't think these names, lat long 1 and lat long 2, are that good. And I think you're right. We actually knew which was the from intersection and the to intersection, and we kind of lost that information. And that turns out, in some of this code, when you go to write this, it's useful to know which end is which of this street segment, and our variable naming we lost that information. No real good reason for that. Info. Okay, yeah, this info. It's not a good name, okay? This is like going to enrage, maybe not enrage, but this will make your TA sad, okay, to see a variable named info. So yeah, these are good points. So let's take a look at the next few slides. I'll go through some of the things that overlap what you guys just said a bunch. Okay, so nobody mentioned this, but the first thing that I'd say about this is it has no vertical white space. Okay, so it is indented. That's good. So this to fit on the slide, I've only indented two spaces per level. Probably it's better to indent 3 or 4, but you can see, you can see the structure of the code from the indenting. I mean, you should always have that. Like, not indenting is it's kind of like writing an essay with no capitalization and no punctuation. Like, it's just terrible. All right, so if you do that, your TA is going to be very saddened. So indentation is like a very basic thing. Okay, they did it. That's good. But they didn't use any vertical white space. And vertical white space is also useful. It basically forms, it's like paragraphs in an essay. It breaks code into related groups. So let's put some vertical space in. Okay, the code takes a little more space now, but it is a little easier to read. So I can see these two lines are doing similar things, these two lines similar things, this is doing something different. And I've broken the if statement has been separated from basically declaring variables and setting up some information before I go in. It's easier to read if you use vertical space. Yeah, and let me go back to a question that Simon has. Simon is asking, should we keep some of these temporaries so that we don't wind up with really long function calls? And I think that's a good comment. We'll come back to that a little bit later. Okay, so the next thing is I mentioned that one of the rules that myself and most people like to follow is limit the scope of your variables. How long they're alive for, how long they're accessible to your program for. And that reduces cognitive load. You don't have to keep as many variables in your head. It also tends to reduce bugs due to initialization. So here I'm declaring all of my variables at the top of the function. So info, some distance variables, this length variable, etc. And also these intersections. And then I use them down here. And some of them I don't use for quite a while. Like I declare length here, and I don't use it until I get down here. So why did I declare it so far above? I declare all these distance variables way up here, and I don't use them until I get down in this else statement. And there's going to be a bunch of code there that I haven't even shown. So this isn't the best practice. It's kind of an older style practice. Early versions of C forced you to declare all your variables at the start of a function. Recent versions of C don't do that, and most other programming languages don't do that, and C++ doesn't force you to do that either. So it's better to declare your variables just where you need them, right? Minimize their scope. We also have another place we could go wrong here is we set length to 0, and we set, let me give a better example of these distances. We set these distances to 0, but then we don't use them until down here. So we have to remember, or we have to look way back to see we set them to 0. And if any line in here, like somewhere in the middle here, were to set them to something else, maybe they're not in the state we expected when we get down here. So that's kind of places where being able to change them in a larger block of code, having to keep them in our mind could trip us up. The initialization is very far from where we actually use them. Okay, so we should restructure this. So this length I just showed you, we declare it way up there and we don't use it till down here, well, and here. A better way to do it, and the distance I just talked about as well. We declared it far from where we use it. So we're going to change this to declare them in a smaller scope, close to where they're used. And that's not much, we don't have to change very much, right? So we just put an int in front of these inter, and now we've declared them right where we use them. And we put double in front of this length, so now we're declaring it right where we use it. And we got rid of that big block of declarations up here. So this is considered a superior code style. Does everybody understand these scope rules? I assume you studied them in 244 and APS 105. So do you understand where these variables are alive for? So you say yes or no. Okay, so I see a yes. See if anyone says no, or maybe everybody's got it. Okay, so I'll quickly tell you anyway, in case anyone's shy. A variable in C++, and this is common in most programming languages, it comes into being where you declare it. So this one, inter1, comes alive there, and it is destroyed, goes out of scope, when you hit the essentially bracket that closes that scope. So this variable is declared inside the scope of this if. When you leave that scope, so you hit that closing bracket, this integer is gone. Same for this one, same for length. Okay, well, length would only come into being here, and it would go out of scope there. So function variables are not really special. This info variable comes into being there, and it goes out of scope or is destroyed when we hit that closing brace. So there's nothing really special about the braces that enclose a function. We can do that in any block of code. We can initialize or declare variables in any block of code we want. Okay, so we've minimized scope. That looks a bit better. Multiple students flagged this, right? The variable names aren't that descriptive. Inter1, inter2, well, it says it's an intersection, so that's good. This says it's a lat long, so we can guess that's a position, and it's in format lat long, so that's not terrible. But we used this 1 and 2, which lost some information instead of from and to. So we used to know which end of the street segment was each of these points corresponding to, and we've renamed the variables so that we don't anymore. And when you write this function, you'll find that there are parts where it actually matters. You need to know, am I at the from location or am I at the to location? So these variable names aren't the best. This one's particularly terrible, okay? This ID. So we're passing in an integer, which is the street segment ID. But we don't indicate that this ID refers to a street segment in its name. And that's really bad. You're going to have lots of IDs in your code because the API we've given you likes to use integer IDs. You really want to keep track which kind of ID am I working with here. So give it a name for that. And it's already flagged. Info is a pretty bad name. There's not much. There aren't many variables that you couldn't call info or val. So those are pretty bad names. This doesn't say that it's the street segment info. So if I put like an SS in front of it or something, and you probably adopt a convention in your code or a street seg in front of it, it's going to be a better name that tells me what's in here. Okay, so these names aren't the best. We also have some redundant temporary variables. So I said that more temporaries can reduce readability because you just have more names to keep track of. So this length variable, I create, I assign it the result of a function, and then I immediately return it. So it doesn't do much for me, and I probably don't really need it. It'll probably be more readable if I don't. I also have these, we already talked about this a little bit, but I have these intersection variables, and they just get passed into the next function. So that also looks like maybe they're not worthwhile. Getting rid of them might make the code more readable. So let's take a look at what happens if we change this. So we're going to try to use better variable names, and we're going to remove some temporaries that aren't doing much work for us, that are kind of close to just renaming values. Okay, so we do that. Let's do it piece by piece. So we renamed ID to street segment ID, or street seg ID, and that's a much better name. Now I'm going to understand in this code what I'm working with. Info was a pretty bad name, so I'm going to rename that seg info. And let's look at this one. Here I have these temporaries, inter1 and inter2. Didn't like the names that much because I lost the fact of which one was from, which one was to, so I couldn't rename them. But I'm looking at this and saying they're only used once. They're just used, they're passed into this function. I don't really want to keep those names around. So instead I'm just going to do this. I just directly pass seginfo.from and seginfo.to into this get intersection position, and now I use that. I capture the result of that into these temporaries, lat long. So what do you think? Let's look at this step, because eliminating temporaries is a little bit of a judgment call. So here's the code with temporaries for inter1 and inter2. Here's the code with them removed. Which one do you like better? So you can just say removed or kept. Just type it in the chat. Okay, so Simon likes removed. Sigrika likes removed. So we got 2 votes for removed. Hopefully someone else has an opinion. If we get to 3 votes and they're all the same way, I'm going to say the motion is carried. Anybody else like them removed, or you like want them back? Okay, so Yusuf also likes them removed, so I'm going to take that as that the silent majority probably likes them removed too. So yeah, I think this is more readable when it's removed. The code is shorter. Shorter code is faster to read if it's still clear. So I like this better. Okay, so then this gets to a question Simon asked of, well, how many temporaries should we remove? Because we still got temporaries. Here's lat long 1 and lat long 2. They're used to go into this function, find distance between 2 points. So maybe we should eliminate them too. So let's try it. Well, actually, before we do that, let's just give them better names. So instead of lat long 1 and lat long 2, we're going to change it to position or pause. And now we're going to keep the from and to, so we know which end of the street segment it came from. We're not losing information. So that's definitely a good change. Our variable names are a bit more descriptive. But now let's look at removing the temporary. If we remove the temporary, whoops, sorry, I'm doing this. Here we removed one more temporary. Okay, so we got length. Length's not doing much for us, so we're going to get rid of it. And I think that's a good change. Okay, shorter, still very clear. There was no real reason that we had to call that length. So this code looks pretty good. Now let's go on to this last one. We've got these two temporary variables. They're only used to pass into find distance between 2 points, so we could get rid of those. And now we get this. So if we don't have any curve points, we can get the distance very quickly. Find distance between 2 points. We get the intersection position of the from intersection. We get the intersection position of the to intersection. And we return that. Okay, so what do you think of this one? So let me erase all this scribbles. So this is one option. And with a couple of temporary variables for the positions, and this is another option where we've eliminated those and just made a longer function, well, kind of a cascade of function calls. Yeah, so Simon is saying it's not terrible, but he likes the temporary variables. So Simon's voting for that one, okay? And Armin's also voting for that one. Anybody else? Okay, so we got Simon and Armin voting for keep those last temporaries. They're doing some work for me. I like them. Anybody like this one? Okay, so we got another vote from Segarica to keep them. So yeah, most people think they'd keep them. I would keep them as well. I personally prefer this code. So yeah, I kind of like a balance. I don't want to see so many temporaries that there's just lots of variable names and there's not much happening and the code's longer. On the other hand, I personally consider this a bit too much work in one statement because I have to kind of parse it, like start here. Okay, what is the first thing? Okay, it's going into this function. What does that function return? Okay, what is this? Okay, it's going to this function. What does it return? Keep in my mind, okay, I've got two lat long points now and I want to find the distance between them. So for me, this actually is a bit hard to understand when I start getting functions, calling functions inside a function call. I like to see the temporaries naming what's coming back so that I essentially I find it more self-documenting to do a moderate amount of work on every line. So I personally don't like this as much. Yeah, one of my former TAs in this course liked this, so there are judgment calls. You know, he liked this one, and I don't like it as much. But I'd say most people find this harder to read, and definitely if your function call gets more complicated than this, then you definitely want to start bringing some temporaries in. It's too much. So I think the temporaries help here, and most people felt the same. So let's look at that, just to remember the competitor. The other thing that temporaries are helpful with is they can help you when you're using the debugger. So when you're running the debugger, you can single step over your code. So let's go back to this case. So maybe I'm concerned about whether this function is correct or not. So I want to watch it execute line by line in the debugger, watch all the variables. So I can single step. So set a breakpoint here. I can look at all these variables. I can say step over one line. I can look at the variables again, step over one line, look at the variables, and so on. So these temporary variables I can actually examine very easily in the debugger, and the fact that I've got multiple lines makes it easy for me to step over one line at a time, seeing what's going on. If I use this version, I haven't actually given a name to this temporary variable, like the lat long of this from intersection. It is harder for me to observe this in the debugger. It's possible if I kind of carefully step into this function and watch what it's about to return and so on, I can actually see it. But because it's not named, I can't just hover my cursor over it, can't just step over it. It is a bit harder to see things in the debugger. And I use the debugger a lot, so I prefer to write code where I can see, you know, kind of most of the variables of interest as I single step through in the debugger. So I would for that reason, go for this prior code. How many of you, well, maybe you guys won't all answer, but if you haven't fired up the debugger on milestone 1 yet, fire it up. Common mistake I see students making is that they don't use the debugger enough. They write code, they look at the code, they stare at the code, they put print statements in. You can make your code work that way. You can ask a piazza, right? So students get frustrated, they ask questions, and it's fine to ask questions, but often those questions can be answered fairly quickly if you watched it run in a debugger. So you want to get used to using a debugger. Once code gets to a certain level of complexity, just you read it first to see if you can find a bug, if you think there's a bug in some code. But if you don't see it right away, you bring up the debugger and watch it execute, because then it makes it much more clear what's going on. Okay, so let's look at what we've achieved. This is the code we started with, and this is the code we wound up with. It's got more vertical spacing, it's got better variable names, it's actually shorter because we got rid of a bunch of redundant temporaries, and we declared the variables closer to where we need them. So I think the code is significantly easier to read. Hopefully you agree. I guess I probably won't get you to type this in because you may not consider it a challenging enough question. But I hope you all agree that this code is quite a bit easier to read. Okay, so that's structuring the code. Let's talk about commenting. So your comments should focus on describing why things are the way they are. So we want the big picture. The big picture is the most important thing. It's the hardest thing for someone reading your code to figure out. When I was actually running my company, my startup, I've told you one of our customers was Altera, and we had to interface with some code of theirs to combine our CAD system with theirs. And this particular code was, it was kind of wicked. It was only a few hundred lines long, but it was incredibly hard to figure out. And I had to spend hours just figuring out exactly what it did because I needed to interface with it. And if it had just had a comment at the top saying, this is what I do, that would have been enough. I really didn't want to change this code. I just had to communicate with a certain naming convention. But because there was no comment, I had to basically go through a bunch of very overcomplicated code, to be honest, figuring out what it did. And it was a waste of my time because I didn't want to change that code. I just needed a comment. And I actually printed out that code and basically pasted it on the wall as an example to our engineers of what not to do. I don't ever want to see code like this. Put like a don't make it so baroque, and then also put a comment saying what it does. So your comments should describe the overall structure of your program and your data structures. If you can understand a program's data, you can usually understand the program. So it's really important to comment major data structures. So in milestone 1, you're going to have some global variables. Every one of those should have a good comment because they're important. Describe why you made certain design choices. Describe what the goal of some portion of code is. And if you've got some tricky code or a complicated algorithm or a special case, you should comment that because that's something that could trip someone up in the future. Before you do that, check if you can make the code clearer. So if you're commenting this code looks fairly bizarre and does the following in this weird way, if there's no real good reason why you did it that way, then just rewrite it to use a more easy to understand technique. If there is a good reason, it's really fast or there's a lot of special cases, then fine, but then comment it. Things not to do not leave commented out code in your project. So you have some code, it doesn't work, it's a failed experiment, delete it. None of your teammates, your TA, none of them want to look at that code. It's kind of a waste of their time. It makes your code base look bigger and longer, but it's not adding any value. Git has all the code you ever wrote. Okay, everything you committed is there. So just make sure you commit it before you delete it, and then delete it. Also, do not translate code to English. So, if you write a for loop, so for int I, whoops. It's not legal, for int I equals 0, so on, rest of a for loop. And if you put a comment above that, for loop, and hopefully, actually let's say this is inter, okay? I would be a really bad name, so say you said for inter equals 0. You put for loop over intersections, and you write that as a comment. Well, I can read your code, and you named your variable in a reasonable way. You called it inter or intersection. I can tell it's a for loop or intersections. So you don't have to write that down. What you should write down is why you're doing a for loop over intersections, or what's the overall purpose of the next block of code. That would be useful, but just telling me it's a for loop and it runs over a variable called intersection is not helpful. Okay, duplicated code. Do not duplicate code. If you see duplicated code, you should extract it into its own function, and that makes your code shorter. It makes it easier to understand because the function has a name that gives a hint as to what it does, or hopefully more than a hint. It also, duplicating code was likely copy and pasted by some programmer. So if you see two blocks of code that look almost the same, probably somebody took one of those blocks, copied it, and changed some of the variable names. And that's a common source of bugs. When people copy a block of code and then start to change some of the variable names, they often forget to change all of them. So you wind up with bugs. And even if you did copy it and change all the variables properly, your code base got longer than it needed to be, so it's harder to maintain and harder to read. Okay, so here's an example of some code that is, let's see, related again to milestone 1. So what this code does is not super important, but it's basically going through all the street segments, and for every street segment it gets some information, okay? Maybe not the best name, we called its street segment information SS. And then basically we're saying, this actually code is a little baroque, so I have to read it carefully. We're basically checking, do we already have that, the from intersection? Okay, so a street segment has, maybe we're doing this for street segment ID 28. Okay, so say that's our SS ID. And that street segment, like all street segments, has a from intersection. So let's say there's a from, and let's say that's 12, and there's a to intersection, and let's say that's 58. Okay, just to make this concrete. So that's what's going into this function. We're basically trying to preload some data. So this might be code from the load map, and we're saying if the data that we've created for to store all of the street segments of an intersection, if that data for the from intersection, so up here, already has this street segment in it, then don't put it in. But if it doesn't have this street segment 28 in it already, then we're going to add it. Okay? So this block of code, and there's a comment, says make sure the ID is not a duplicate for the street segment from intersection ID. So maybe not the best comment, but reading this code and knowing what it's trying to do, which ideally they would have given me a better comment, what it's trying to do is check if in the data structure for from intersection 12, whether the street segment ID is already in there. If it's not already in there, then add it. And then this code down below, basically doing the same thing for the other side. For sort of this to intersection, it says, okay, is this street segment ID, number 28, already in its data structure that stores all the street segments that impinge on this intersection? If it's not, then let's add it. Okay? So that's what the code did. I kind of just went through and explained it to you. What do you think of the readability of this code? Is this code easy for you to understand? Could it be easier? What do you think? So take it a shot. If you've been waiting to answer a question, there's no right or wrong answer to this. You got a 50-50 shot of, well, it's all stylistic, so there's no perfect answer, and there's only two choices. Could make more readable or could not make more readable. So what do you think? Could it make it more readable or not? I believe someone has to have an opinion, right? Like, okay, so I'm going to give you a hint. I don't think this is that readable. You saw that I know what this code does, and I had to kind of look at it carefully so I could try to explain it to you. So I believe this code could be made more readable. How could we make it more readable? And it's using some of the principles we've just talked about. Like, there are some things about this code that I don't like. So what do you think? Any ideas? How could we make this more readable? More temporary variables. Yeah, okay, so we could use some temporary variables. The variable naming is not great. Like, I don't really like this SS. That's not helping me very much. Let's see. It's hard in this case. There are not a lot of places I can put temporary variables because I am actually just doing. I'm making 2 function calls, so not a lot of places to put temporary variables to help me there. So temporary variables are really not going to help too much. But I could name my variables better. I don't think this comment is fantastic. You know, it tells me something, but I think it could be more explicit. I gave you a description of what's really happening here, and ideally that would have been in the comments. So let me go through, well, let me give you a look at this block of code, okay? And then look at this block of code. What is different between them? They kind of look similar. So what's different? Yeah, just the to and from. This is repeated code, so this smells bad. You look at these lines of code and you go, this block of code and this block of code are the same. The only thing we've changed is we've changed SS from, because one of them is working with the from intersection. So if you go through this, you'll see SS from all over the place. And here you'll see SS2 in all those same spots, except this one. That's actually SS from again. Why is that one SS from? Does that make sense? We're actually looking at this to intersection. We're seeing if we've already stored this street segment ID 28 in the vector of, you know, street segments that connect to that to intersection. And if it's not there, we actually push back that street segment ID, so number 28, into SS from's list. Does that make sense? Or SS from's vector, technically. It doesn't actually make any sense. Okay, that makes no sense. I'm actually looking at the to intersection. I'm seeing whether or not I've already captured, you know, this street segment that I'm looking at in the vector of street segments connected to it. This is a copy and paste error, and it's actually hard to see. I copied the code. I changed most of the froms to to. I missed one, and this code is now broken. It doesn't do anything useful. So yeah, it kind of highlights why duplicated code is not good. So it's not good because I have more code to read, and it's not good because it's easy to make these copy and paste errors. So let's rewrite it in a function. Okay, so let me get rid of this actually. Okay, so it's almost identical, duplicated code, and we have a copy and paste error, right? One of the froms didn't get changed to to. So let's rewrite it with a function. So as soon as you see duplicate code, you should say function. And this function is not going to be very long. You know, it's only like 3 or 4 lines long, but that's fine. But it's still going to clean up our code. Our code now looks a lot shorter. And we've given a name to what we're doing. So instead of reading, basically what this code was doing is I was saying there's a STL function called standard find. So standard find was basically looking and seeing between the beginning and the ending of the vector where I'm storing the results, do I actually see this value? If I don't see the value, so basically that's the end value, then I'm going to push it back in my vector. I'm going to store it. So that does an insert in the vector if it wasn't there before. Okay? And the comment, you know, kind of told me that's what I was doing. But if I extract it into a function, it actually gets a name. So I give it a name of insert unique. And it's a lot easier to read. Intersection, street segments. So this is the vector. And this is what I want to check. Is it already in there? If this integer is not in there, then insert it. And I'm doing exactly the same thing here. I'm just changing which vector. So now the vector for the to intersection. It's a lot shorter. It's a lot easier to read. And the name helps because it tells me what I'm doing. So hopefully you agree that's clearer. What do you think of the comment? Okay, so we got comments here. Comment there, comment there. So read those. Tell me if you like those comments. If there's anything you do to try to improve it. So what do you think? Any idea on how you could improve those comments? what's different about these comments? First thing is, like, I have two comments. They seem, again, very similar, right? Yeah, so the comments are identical. So Sagarika's right. The comments are identical, except I changed SS from to SS2. So grouping them seems better. Why did I write this twice and just change the variable name? It's kind of like duplicated code. It's basically like a duplicated comment, which still isn't great. Tell me once and give me more of the big picture rather than this really detailed comment twice. Also, by putting the variable name in here, there's an increased chance that that I might get it wrong. If somebody goes in and renames this variable later, this comment will be wrong. So probably wasn't even helpful to put the variable names in there. So if I group them and I go to a little bit higher level, I say add the street segment if it's not a duplicate. It's a bit shorter, but it gives me the big picture. The name of the function is pretty clear. So this block of code is easier to understand. It's grouped related operations. They're short because it's just a function. The function has a name so I can tell what's doing, and the comment just gives me a little bit bigger picture. Add the street segment, it's not a duplicate, and I do it twice, to the from and to the to. So, this is definitely shorter, definitely easier to read. Okay, so that's it, what we're going to talk about today for code style. So just to summarize, good code style reduces your cognitive load, so you don't have to keep so much stuff in your memory, and it explains why you're doing things, that big picture. Key things to keep in mind as you're trying to achieve good style is short functions. The vast majority of people write functions that are too long, so try to write short functions. Descriptive variable names, keep the scope of your variables small. So you're going to need some global variables in milestone 1. So that's okay, but try to minimize the number of global variables. Try to group them together into structures or classes. The other variables within your functions, try to minimize their scope. Comments should focus on the big picture, talk about the goal of what you're doing, the why, and do not have duplicate code, which you will not have much duplicate code if you tend to write short functions and reuse them a lot. Okay, so code style it's a big topic. There are lots of discussions, lots of books on it. So here are a few books if you'd like to read more. And there's a talk you can view online if you want to see a talk on code style. Online resources. So there's a Google code style guidelines. There are many code style guidelines you can find online. The Google one is quite good in my opinion. It's long. Okay, so this is it's more detailed than you need. It goes through all sorts of rules about, Google has a style guide for basically every language they use. And C++ is one of the 3 major languages that they use for their infrastructure. So they have a detailed style guide on it. Some of them we just talked about, write short functions. So, and they don't just tell you that you should do this, they tell you why. There's more in here than you need. They're talking about the whole C++ language, so you don't have to go read all of this, but it has good information. In this course, people also can get into very detailed things about, do I use underscores or do I use what's called camel case, where I name variables. Let me go back and show you. Let's see. Yeah. So people sometimes get into very detailed questions of, do I prefer, inter from, sometimes called snake case, or do I prefer inter from, sometimes called camel case? We don't really care. Use either. It doesn't matter. We just want to see meaningful variable names. So when you're reading about code style, really picky rules like that, sometimes companies have them. They're not that fundamental. What you want to focus on is more of the fundamental things that we talked about in this tutorial, and I'll talk about it again in a lecture. If you go read this Google style guides, it's kind of the higher level structure that they're talking about that you want to focus on. They also have information about all sorts of detailed language features, which are interesting, but some of which may be more than you want to read at this point, and that's fine. So that is all I had to say today. If there are any questions, let me know.